Hello, and welcome to the Poor Man's Chemist. I'm your host, the Poor Man himself, and in this video we are going to be making hydrobromic acid from disulfur dibromide, which we will synthesize just by the union of the elements sulfur and bromine. This is a synthesis that I came across on prepchem.com when I was looking for something to do with all of this bromine that I recycled. And this seems like an interesting synthesis in that it has a very high yield. And the only thing that is really required is to just make the disulfur dibromide just by mixing together sulfur and bromine, and then carefully, over the course of about an hour and a half, adding that to ice chips and letting it all melt, and then fractionally distilling the liquid that results to get quite a bit of hydrobromic acid. So, sweet, that sounds pretty easy. The only thing we have to do is deal with bromine fumes and disulfur dibromide that I've never worked with or seen, or even honestly know a whole lot about beyond what I read in the SDS, which makes it sound like some kind of chemical holocaust in a bottle. So this should be fun. So, I'm doing this in the latter part of the day when it's nice and windy with my trusty box fan, because, we like living dangerously here at the Poor Man's Chemist. So we're just going to jump right into this and give it a try and see what we can do. Now, I don't have the actual synthesis calls for 150 grams of bromine. I've got about 146. So what I'm going to do is I'm going to add in my bromine, and I'm going to weigh the bottle before and after I put it in there. That way I'll know exactly how much bromine got put into the flask, and I'll know how to adjust the weight of sulfur accordingly. Alright, so let's go ahead and get started. Come on, Frody, come on. Good dog. Yes, keep all, pets, children, whatever, away from the bromine. Alright, it is probably impossible to tell on the camera, but this really has changed to kind of it is more of an oily liquid. It's not quite like regular liquid bromine, which is why I'm not turning the fan off, so sorry if y'all are having a hard time hearing this. But it does have a slightly different consistency of bromine. So, that's interesting. So, again, because the amount of information I could find out about disulfur dibromide and as far as like health and safety was kind of limited, not what I would call satisfactory, not for myself anyway. We are going to do this over here, far away from everything. Still going to put the fan over here so that it is sucking all this stuff away and blowing it out into the yard, where hopefully all of this wind will just dissipate it. Really hoping that's how this goes down. So, if not, it'll all be on film. So anyway, as soon as I move everything out here, we will get this party started. Okay. So chilling is supposed to be maintained throughout the hydrolysis. Once the red color disappears, we will add the next third of the disulfur dibromide. Alright, I'm going to stand back here so you can hear me over the fan. But I discovered something. So I went ahead and, let's see here, dumped out the ice. And I replaced it with just room temperature water in the water bath. And I let it sit there for a few minutes. And I came back and the bubbling, maybe this will work. And the bubbling inside the flask had really picked up. Now, I put a little bit of ice in there, and it seems to have slowed down again, but I wanted to just give you a look as to what's actually going on here. Every now and again you'll see a bubble come up here or there. Again, before I put some more ice in there, it was bubbling like you were seeing several bubbles a second. Now it's slowed down quite a bit. So I think that it's very temperature sensitive, and if you cool it down too much, it will dramatically slow it down. And I think that was what my mistake was before. I think that I cooled it down too much and it slowed it down too much. Now, it doesn't seem to be... It doesn't seem to go at a super fast rate. Now, again, I mean, that's with it there still being ice inside the flask. So, take that into consideration. It wasn't like there was only water in there. There was still ice in there keeping it cold. So I would imagine that cooling is probably essential, but you probably don't need to go super overboard on it either. Alright, even though not everything in the flask has reacted, it's been over 2 hours. So I am going to go ahead and add the remainder into here, and I guess just leave it overnight if that's what it takes and see what happens. Maybe the reaction is just slow for some reason, I'm really not sure. Nothing bad to happen to you, big guy. safe. Just trying to be safe. Wow. That stuff is just disgusting. My God. Well, that was interesting. Ah, still smell. That's what it finally decomposes into. So, now we know that when a reaction is done, it should look like this. But right now, it more looks like this. But as we saw from there was a lot of gas produced, but it wasn't violent. So I am going to let this basically just kind of come to temp, and let's just see what happens. I'll tell you what, droplets of it do not break down quickly. Because there are droplets in the container in there. And it takes them a little bit to break down and go away. Alright. So, based on everything I've seen, we're taking a new approach, which is to put it on the stir plate and let it stir with no heating, because it's just not doing anything sitting in there. Droplets of this stuff that have fallen into the water have not reacted vigorously at all. In fact, it takes a copious amount of water to get them to finally dissolve. This thing is not generating any heat that I can detect. So I'm gonna let it stir for a little bit and see what it does. I mean, I guess the worst thing that can happen is that it'll generate gas and foam out and blow the top off of it, and that'll suck. But nothing that I've seen thus far makes me think it's going to do that. So we're going to go with this and see what happens. So this thing has been going now for the better part of 18 hours, and it's almost all completely gone. There's just a little bit left there, not very much, and I imagine that that will probably react and be used up when we do the distillation. So the next step in the protocol is to fractionally distill this mess, and that is exactly what I'm going to do. It is a straw colored liquid, exactly like we were supposed to get. It's just the protocol, the way it was written, made this sound like it was going to be a very energetic reaction, and that it was going to be done in less than 2 hours. While it does give off just a ridiculous amount of heat, if you take it out of the ice and just stir it, as I found last night, you know, it doesn't go in some runaway violent reaction, although it might if you just let it keep going. But I mean, it does get ridiculously hot, but it does take it like about 30 minutes to do so. Maybe not quite that long, 20-30 minutes. So it's not the, you know, horror show of reactivity that I was thinking it was going to be. Again, I guess I lucked out. It's a nice, slow, reliable way to make hydrobromic acid if this turns out well. And I mean, the way it was acting yesterday, I don't see, maybe, yes, it makes sense to stagger out adding in the disulfur dibromide to the ice and everything. But if it's in an ice bath and it's well cooled, I don't know. It almost seems like you could just add it almost all at once or in just 2 goes that are not that far apart. But I don't know. I'm basing that off one experiment. So maybe my stuff, I'm sure it did have impurities in it that slowed down the reaction. Maybe that's what happened. I don't really know. But it worked. So there's a little more water in here than if I exactly followed the protocol. It would have been somewhere in the area of about 200 mils. I've got about 350 here, a little bit less than that. But that's fine, and fractionally distill it, it will all come out in the wash. We'll just, that fraction that comes out before azeotropic hydrobromic acid, we'll just collect and keep as dilute hydrobromic acid. Or just chuck it back into bromide recycling and recycle it for the next round of making bromine. So, fingers crossed this works, because if so, I've just found myself a nice, easy way to make hydrobromic acid, which would be awesome. And if it works, I mean, theoretically, every atom of bromine that goes into this reaction ends up as hydrobromic acid in the end, which is freaking great. It's just wonderful. And you can do it straight from elemental bromine. That is a huge plus. You can make bromine all day long. That's easy. So, anyway, I'm going to set up the fractional distillation, and we will see what we get. Okay, so I am fractionally distilling off the hydrobromic acid, and it has just now reached 124 and change. So we're just now getting actual hydrobromic acid over. And I should probably go and raise this thing back up, huh? That might be good. Okay, now, things that I've noticed. One, I'm going to bring you closer here. This is what I got. This is the dilute hydrobromic acid that came over before the azeotrope that's just starting to come over now. And you can see that there's little bits of solid sulfur mixed in here. If that turns out to be true for the hydrobromic acid as well, I don't know that it's really that big of a deal. I mean, filter it through some glass wool would probably take out all the big chunks. And I mean, I guess push comes to shove, you could distill it a second time if it's really necessary. But if it keeps up like this, hopefully just filtering it through glass wool will be all that's necessary, if anything is at all. Now, let's see. I don't know if you can see it. In fact, I'm just going to take this thing off here and maybe you can see it this way. There we go. So you can see where we got elemental sulfur there coming into the tube, going into the receiver. Now, I don't think it's still doing that. Oh, there goes a piece of foil. It doesn't look like it is. But I don't know. It is kind of a weird color. Let's see if I can get it to actually... There we go. It's kind of a peach color almost. I don't really know what to call it. A very light peachy brown. But anyway, so, yep, get the focus. Come on, the focus. So, there we go. It's at the magic temperature. This should be the real thing, and given the volume that's left, and this is all that, and this is all that came over. I mean, beforehand, I don't know. Yeah, there's a couple little pieces of sulfur. Okay, so again, we have to filter it through a little bit of glass wool. So what? I know, I don't know why it won't focus automatically. It does sometimes and it doesn't others. I really need a camera that isn't my phone. So anyway, I'll let it keep going and see what we get. Alright everybody, so it ended up where I just went ahead and centrifuged the acid in order to get the colloidal sulfur out of it, because I could not think of an easier way to do it, but that seems to have done the trick. Now, this is only the first half of it. I haven't even done the other half is about to come out of the centrifuge, but this is what I've got. If this is 100 mils here, that's about another 100 mils in there, which means it will have about 200 milliliters total of nice, crystal clear, azeotropic hydrobromic acid from this method. And I don't care how you slice it, that's pretty damn good. So I have found my new method of making hydrobromic acid from here on out, because this is just so much more efficient, so much easier than everything that I've done up to this point. So I hope you've enjoyed watching this. I've certainly enjoyed doing it. Please feel free to leave comments or ask questions, criticisms, tell me how much I suck, tell me how awesome I am, whatever the hell you feel so inclined to do. Everything is welcome. So thank you for watching, and until next time, people, take care.